All right, here we are going to solve another rational equation. This one was 5 over x plus 2 equals 1 over x squared plus 7x plus 10 minus 3 over x plus 5. Even if it doesn't say, we need to remember that when solving any rational equation, that we need to be stating our restrictions. Now, sometimes it might be a good idea to state your restrictions at the beginning. So in the last example that we did the restrictions in the last step. Now, let's at least try to put down some of the restrictions that might be obvious at first. Let's try to put them down at the beginning of the problem. X is the variable that we're working with. A restriction tells us what x cannot equal. We cannot have values of x that will make the bottom or denominator 0. So if we look, I do see 2 linear factors already in my problem, x plus 2 and x plus 5. Linear factors are where we like to look for our restrictions first. So what restrictions do we have on x? You can shout out and tell me what x is not allowed to equal. If you participate a lot, if you want to wait a few seconds for someone else to jump in. If not, just go for it. If no one else does. X can't equal?
-5.
-5 is one of them. What else? X cannot equal? I see another one.
-2.
Yes, good. X cannot equal -5 and x cannot equal -2. Now, that's from here and from here. This might give us something different, but let's just be upfront right now, guys. It's probably going to give us the same, right? Like the factors of this, look at the numbers, 7, 10. Look at these linear factors, 5 and 2. I mean, what do 5 and 2 add to give us? What do 5 and 2 multiply to give us? So that's a cheap trick in factoring your quadratic trinomials, is to look around at the rest of the problem and be like, oh, these are probably involved. You don't want to assume anything, but, you know, you use the clues that were given to you, okay? So I have this -1 on top. I'm going to factor this quadratic trinomial. I got to see all my factors. And then -3 over, and then I got that x plus 5. So would it be a good idea? Does this factor to these two things, x plus 2, x plus 5? Or would that be a trick or a trap? What do you think? X plus 2, x plus 5? Yay or nay?
You would break it down to its factor form, so yeah.
It does work? X plus 2, x plus 5? It works? It does work. So that's your cheap trick. You kind of look at the other factors and think, can I use these other factors to factor the one that's not factored? And it does work. So stage 1 is done. Now, next stage. Next thing we need to do is find that comm denom. So what do I need to multiply my first fraction over here on top and bottom by? My second fraction, my third fraction. What do they need? And I am going to do this one slightly different than the last one, but I'm going to talk about it first the same way. What would this need to be multiplied on top and bottom by to get started? Not all at once, guys. I might be overwhelmed. So, x plus 5. Good. This one already has x plus 2 and x plus 5. And what would this one need on top and bottom?
X plus 2.
The x plus 2. Okay. If we did that, we do that multiplying like we did in the last example, and then we would combine the two terms over here because there's a plus or a minus and bring them together. Then we would have the 1-to-1 property, and we could dismiss the denominators, as Paige said, and just look at our numerators. However, I'm going to show you this one using the Miss Thomas method that I showed you when we were doing other examples, where I got rid of all my denominators. I got rid of them in one big step. Who remembers? I'm going to do like big parentheses, like this over here to really draw a lot of attention to them, okay? Big ones like this. Who remembers what I did, what I multiplied everything in my problem by, and that got rid of all my denominators? What did I do on those earlier examples? They were like kind of like baby examples getting us ready for this unit. What did I multiply everything by that got rid of all my denominators? Anybody remember? We use the 3-letter abbreviation. Ella, Natalie. Anybody remember? Marta, Isa. 3-letter abbreviation. We multiplied everything by the blank, 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 blank.
The lowest common denominator.
Yeah, Jabari. Yeah, the least common denominator. We multiplied through by it. What would be my least common denominator for this problem? What would be my least common denominator for this problem? What would be, if these were my 3 children, what would they all need to have so nobody was crying and jealous? What would they, at the end of everything, when you gave everybody what they needed, we just said what they all needed. What would they all have as their denominator? What would they all have?
I'll be right back. I'm gonna go get a sweater.
Okay. Thanks. Adriana, what would they have?
X plus 2 and x plus 5.
Yeah, they would all have an x plus 2 and an x plus 5. So I'm going to multiply everybody by x plus 2, x plus 5. Now, this is where I always say to think smarter and not harder. And when you multiply it through, we're all looking for those places where we can cross stuff out. All right. So if I distributed this beauty, least common denominator over here, if I distribute like, woo, over here, what crosses out? If I took this and multiplied it over here, what crosses out? This is in x plus 2, x plus 5 over here on the right. That's the numerator. 5 is also in a numerator, x plus 2 denominator. What crosses out? You could do it.
X plus 2.
The x plus 2's, adios. And what's left? The 5 and the x plus 5. Woo, that's nice. Here, now we distribute here in the middle. Lots crosses out now. By x plus 2, by x plus 5. What's the only thing left? Only thing left? Negative 1. Minus, distribute this to this. What crosses out? What crosses out?
X plus 5.
Yeah, by x plus 5. Careful now, what's left? The negative, got it. The 3 and the x plus 2. Oh my gosh, this is so much cuter than the line before it. How much cuter is that? I mean, I don't even have words. Now we just do some classic distributing. Sean, you know, jump in and participate maybe soon. We're gonna do some classic classic distributing over here. And what do I get for this next line? If I distribute that 5, there's my equal sign, my negative 1. I'll distribute this minus 3. Anybody want to tell me what I have on the left? Maybe Hashara, Tahani, Natalie, Manuel.
5x plus 25.
5x plus 25 equals negative 1 minus, all right, what about over here? What do I get? Blue, blue. What do I get?
Negative 3x plus 6.
Plus,
Wait. Oh, wait. Negative 3x minus 6.
minus. Make sure you distribute that negative. I think if every math teacher had to get a tattoo on their forehead, on their forehead to deal with for the rest of their lives, mine would say, and most teachers would probably agree, did you remember to distribute the negative? Because every time a student's like, I think I messed up somewhere, or I didn't get that answer, I'll point to my forehead. Did you distribute the negative? Because most of you don't. All right, now this is a cutie patootie for me to solve with no problemo. Let's combine like terms first. What do I get if I start combining like terms over here? Anyone gonna jump in? Come on, especially if you've been quiet this whole time, get this opportunity to participate.
Negative 7.
Yes, boo-boo, thank you, negative 7. Here's my negative 3x is still there. I got that 5x plus 25 over here. All right, smooth sailing, keep it moving. What do I do to both sides? We could add something. What could I add? What could I add? We're wrapping it up right now. I'm solving for x, honey bunnies. Solving for x. What do I add to both sides?
3x.
Yes, yes, and yes. We add 3x to both sides. And if I add 3x to both sides, what do I get for the next line? We're almost done.
8x.
We get an 8x. I'm just going to go right here. 8x plus 25. -7. I'm just going to rewrite that. You guys should all have it nice in your notebook. What do I do next? Help!
Subtract 25.
Good. Subtract 25. I heard from 2 of you, Melvin and Hashara, I think. Yeah. Good. 8x equals what then?
-18.
Both are negatives, -7 and -25. So you're going to add them together and make it negative. Add them together and then make it negative.
Oh, -32.
-32.
-32. Okay, one more step.
Divide both sides by 8.
You got it. And if we divide by 8, we get that x equals what numero?
-4.
-4. Loving it. Is that number allowed or is that number on my list of restrictions?
The number is allowed.
It is allowed. Good. And that is the end of that example. All right. That's the end of that example. And all I'm going to do right now is I'm just going to give you one last problem to do on your own. And I really, really, really want to see this one. This is going to count for double. It's going to count for double. So let's do I just want to make sure I don't pick anything too spicy. Let's do. All right, I'm going to pick one I think's pretty nice. Homework. On your own. Do your best. We're going to solve and state restrictions. Of course, state restrictions. If you need help, just come by after school. I would say come by after school today. All right. Solve and state restrictions. Okay. 7x plus 1 over 2x plus 5 plus a big fat 1 equals 10x minus 3 over 3x. So your homework, solve and state restrictions. Here's the problem. And do you want a clue about how many answers there are? After all is said and done? Or do you want it to be a mystery? What do you think? There's going to be a certain number of solutions, certain number of restrictions, and then we'll also have the final, well, no, we don't have to say final. We could also say somewhere maybe when we're solving, I'll indicate the least common denominator. You could do either method. The one in this video is where we got, maybe you could tell me what the least common denominator is. We could say something like that, you know? The one method is my method where you clear out your denominators. And then in the other example, and I'll try to get those both uploaded now, the other example method is where you find the common denominator on everything, and then you dismiss the denominator and use the one-to-one property, okay? So good luck on this. If you think you got it, thumbs up. If you don't think you got it, thumbs down. But I think you guys could do this and have a wonderful day, all right?